Hello, my name is Brian Hammonds, Principal Specialist for Amazon EKS. Today, we're going to talk about building a modern data platform on Amazon EKS. A little bit about the agenda today. So, we're going to start just to kind of talk about a little bit of the growth and transition within the Kubernetes space in terms of data, why folks are choosing to run data processes on Kubernetes. Then we're going to talk a little bit about one of the programs that we're running this year, Data on EKS. And this is going to speak in terms of how we're enabling customers and offering up certain patterns to help them in their journey. We're going to then talk about a number of different patterns and use cases that we're seeing, and then also talk about kind of what this has meant for some of the customers going through their data modernization journey. So then I'll close with a couple of next steps and set it up for a Q&A. All right. So to get started, why data on EKS? Our data on Kubernetes, for instance. Let's sort of start in terms of looking at where we've come in terms of data volume over kind of at this current state, but we'll talk a little bit about the growth in this previous few years and even the last decade. So looking at and pulling from a couple of industry reports, it's now been predicted and stated that data-driven organizations are growing on average 30% annually. But also 68% of organizations have reported that they're still unable to realize the value from that data. And then only 28% of survey participants actually have a data strategy in place. Now, what's at stake here in terms of actually succeeding in this mission of implementing a modern data strategy? So, in a report by Forbes, it was noted that $65 million is the increase in net income by company, and that's only within companies or enterprises that realize 10%, make use of 10% of the data that they have available to them. And those same enterprises reported a 415% 5-year ROI, and also a 48% reduced cost to total operations. So for those that actually start making use, even start to actualize the power of even a portion of their data, they're setting themselves up for huge returns. So alongside this trend, let's take a look at kind of something that we've seen in terms of the rise in Kubernetes since 2021. And this is when, I consider Kubernetes to have crossed the chasm into mainstream adoption, where, at least according to the 2021 survey, 96% of organizations are using or evaluating Kubernetes, and 5.6 million developers are using it, which has been a jump of 67% from even the year preceding it. So EKS currently is the most popular of those managed Kubernetes services. But the other thing to kind of make note of is also the rise in analytics, AI, ML, database, and streaming workloads on Kubernetes, starting as in the beginning as for most people, they believe that Kubernetes is just for stateless workloads, but that's actually not what we're seeing in the broader ecosystem, or the broader community, or even on EKS. So a large portion of workloads that are being run are actually these stateful workloads for these particular processes. And then of those workloads, a large number, 63% of of those reported are running things like Spark on Kubernetes, or other things like Presto and Kafka, for in terms of distributed query languages, or streaming streaming data solutions. So why are customers choosing to run data workloads on Kubernetes? Well, and you'll see that this maps a little bit into terms of like the broader ecosystem trend. One of the reasons why folks choose Kubernetes in the beginning, which is it's highly scalable, right? So it has the ability to run, up to thousands of nodes, a lot of parallel executions. It's very powerful in terms of its orchestration and scheduling capability. Better resource utilization, right? In terms of some of these data processes, you can run uh, uh, finely packed. You can pack a lot of different work or different workers onto the same node, and make the most in terms of utilization, right? Uh, Things like diversified compute and storage options, right? When you're especially on something like EKS, you're able to really make use of of your cloud compute options, things like EFS, FSX, S3, and EBS. So the diversified a storage pool, and then also different compute options in terms of different instance families, Graviton, Mac 1 or M1 instances. So very diverse. And then also things like security and multi-tenant isolation. So and that's something that really is enforced through some of the standard isolation boundaries, whether they're soft at the namespace level, or even at the cluster level, which we would call like a hard isolation boundary. So you have the ability to run single or multi-tenant executions, and then also cost, right? And this really ties in with resource utilization. So the ability to be efficient in the use, to make the most of the compute, while also being able to scale at cheaper or reduced cost. And that's actually even in using different compute options, like things like Spot, for instance. And lastly, just the broader open source community, the ability to access a number of these data frameworks, platforms, AI, ML solutions, and batch processing solutions. So that's some of the reasons why folks are choosing to gravitate towards Kubernetes for data workload execution. Uh, and now you'll see some of the challenges, though. It comes with some challenges, and these challenges really map, interestingly enough, to some of those positives, right? So when especially some of the trends that we see when scaling some of these data intensive workloads is scaling beyond 1,000 nodes. The Kubernetes maximum, or stated maximum, is about 5,000, but for these highly resource intensive nodes, or highly resource intensive jobs, it places a lot of demand on the control plane, and rather even in cluster performance, and the number of mutations that are being run, in the rate of execution, and so on. So different mutations, CRDs. So it's definitely a challenge for folks to perform optimally at scale. Considerations for high availability, to fault tolerance, and failover, right? So with stateless, it's not, you can always distribute things in an unordered. You can often distribute workloads unordered, and the considerations for failover are not as complex, but within stateful operations, when you need to keep data highly available, when you need to increase access to data or improve access to data, right? So failing between between regions, or even between availability zones, it presents a little bit more of a challenge. A couple of other challenges would be things like observability and monitoring, right? So the ability to see, especially as you're scaling to millions of microservices, what's actually running, really lining up things in kind of in sense of like the Spark history server, for instance, with different metrics that you're collecting from CloudWatch if you're using a monitoring solution like that, or Prometheus or Grafana. So other challenges that we've collected and noted is network configurations. The same, being able to run multi-tenant clusters and workers, and then also the just choosing the right compute and storage options. Right, you have a number of choices, so really right sizing and fitting the right ones that work for your workload. That creates a bit of choice. Uh, so this is really what some of the motivations behind data on EKS. So what is data on EKS? Data on EKS offers open source patterns to modernize your data platform on EKS. So we offer a number of different tools and utilities to help users advance in their data journey. Things like infrastructure as code templates. So we offer Terraform-based IAC, and then also have connectors for CDK as well. Performance benchmark reports, to be able to see how your workloads are running on especially these different data workloads are running on the compute and storage selections of your choice. Best practices, and this includes best practices for a number of different data workloads. So we have patterns for Spark, we have patterns for Kafka, Ray, and then also for things like Kubeflow. So and then lastly, different deployment examples, some of which I'll go over in today's session, and different architectures that will help you along. So I've included the QR code that will take you to the Data on EKS portal if you'd like to learn more. But this is an open source solution, and you'll be able to pull some of these patterns down, contribute, or just read some of the findings that we've really gathered from working with customers at scale during our journey with EKS. So a couple of different focus areas, and it's broad, right? So, and then the vision of this is kind of that end-to-end modern data platform. Some folks might be just part way into this journey. Some might be kind of at the end of the spectrum. But this is, as best as possible, a bit of a representation of some of the workloads that we see run on EKS. And then also kind of aligned would be some of the managed service complements that could also be used in complement of these data workloads running on EKS. So the top would be the open source solutions, which are broad. There's a number of different options folks have to choose to run on EKS. And then the thought here is that if you're only self-managing, if you're kind of staying at the top of the spectrum, that is difficult to say the least, right? So because of the number of different elements involved, it's kind of important to at least make visible the different options or managed options you might want to implement in order to make the end-to-end maintenance and upkeep a little bit easier. Also kind of on the side would be different storage options, and then the plethora of AWS service integrations that would also help with upkeep, extendability, availability, and all those good things. All right, so moving into since we're only going to have time to focus on a few different parts of this, the different uh, data platform strategy. Let's talk a little bit about data processing and analytics. So, on to the rise of Apache Spark. This is a technology that we're seeing uh, rise pretty rapidly on EKS due to a number of factors. One, the explosion of data volume. IDC, in a report by IDC, um, it was uh, uh, it was estimated that as of 2022, um, data volume has grown to the scale of about 100 zettabytes. That's a lot of data. And to put that into perspective, that roughly correlates in 2022, 2023, these last 2 years, into the rate of growth exceeding even the last 10 years combined uh, as in terms of data volume, right? So, and along with it has also come an explosion of personas, a number of different business units and organizational customers that actually need access to that data in order to drive faster and better decisions, the types of decisions that help differentiate them in their business, right? So, how does Spark help with this? Well, Spark is estimated, especially over traditional Hadoop-based workloads, to be faster in terms of how it's able to perform these executions and be more efficient in terms of CPU and memory usage, the ability to do more with less, and to be able to run them in terms of more parallel operations. Now, when talking about running Spark on Kubernetes, well, that's even a bigger draw in terms of, again, kind of pointing backwards, the ability to now run Spark with different things like distributed storage options, right? Different types of cloud compute. So you're able to decouple some of the data elements of it, where a lot of times that previously that was localized, and really make use of highly available fault tolerant data storage that's still going to perform at low latency. So how does the Spark on EKS? How does Spark on Kubernetes look? Well, um, in a traditional format, it's just Spark submit that's submitted to the Kubernetes control plane, and then at that point, uh, it kicks over to schedule a driver pod, uh, and then request executor pods, and then the executor pods are scheduled. Uh, and then the watch events are then set up for these executors. So it's relatively clean in this implementation. This is done via Spark Submit. We do have a pattern available on the Data on EKS repo for an implementation via Spark Operator, in which case Spark Operator would then be the conduit for which Spark Submit gets executed. The other thing to note here, in terms of being able to run Spark, at least on EKS, is the different means in which we can make use and store the drivers and executors, right? So the drivers themselves can be stored on demand or reserved, while in terms of instance pools, while the Spark executors can be stored in things like Spot. So there'd be the ability then to have cost savings, even there, in terms of how you're mixing and matching and how you're running them in different node groups, right? So, and then kind of moving and talking about really another service for doing this. Again, I mentioned Operator before, but we also offer Amazon EMR on EKS, right? So this is a way of a managed offering for you to run Spark on EKS and to just minimize the amount of overhead, the amount of infrastructure management that you're going to be able to do, or that you're kind of made to do. And then there's a couple of benefits here. One is the consolidation of infrastructure across the organization, right? So within a single EKS cluster, you can run multiple different versions of Spark. You can run different applications, so you can actually localize some of these compute resources and infrastructure resources together. You can manage resource limits by team and by workload, right? And then also start jobs quickly. You don't have to worry about cluster provisioning delays, and you can run them in multi-AZ or single AZ configurations. Now, the decision to do one or the other would be a conversation about speed and performance versus high availability, for instance, right? Since running in a multi-AZ configuration and communicating across AZ, there might be an initial latency or even cost component to that, but the flexibility to make that choice and to run the workloads in that way is definitely an option and offering to customers, right? So, and then lastly, the ability to run serverless via AWS Fargate on Amazon EKS. So again, serverless executions to again increase and improve the management burden on your operational teams, your platform teams. So, and just to kind of look at the dimensions in terms of making these considerations, one would be kind of the self-managed on the left, self-managed Spark on EKS, which will give you and it's a flexible option for running open source Spark. You have access to all of the open source integrations that are compatible within the community, portability and versioning. Right. So this is really for customers that want to standardize on EKS, but are willing to maintain the open source components. And then the option we talked about previously, which is EMR on EKS, which offers a low TCO and fast performance. It's secure by default and easy to use. Right. So similar to that, it's the ability to run multiple versions on open source framework, all on the same cluster. And then on the far end of the spectrum, things like EMR serverless, automatic fine-grained scaling, resilience out of the box to AZ failure, and then also enabled for shared applications, tightly integrated with different ecosystem toolings from Amazon or AWS. Yeah, this is really for folks that want to be able to run Spark in the most simple of way, with peak simplicity, right? All right. So just looking at an end-to-end Spark processing pipeline, at least on EKS, this is a good representation of one that we would typically see, and you'll kind of see. On the left side, the number of different data sources that the data is kind of being pulled from, and then also you can see the Spark workloads themselves are being set up. Both the Spark workloads and then also the notebooks are being run on the EKS data plane. And then kind of on the orchestration side, I've taken another look at what's happening on the orchestration. You'll see a little bit of a variability here, and this was intentionally added just to talk a little bit about the composite nature of Kubernetes, right? So being able to use a purpose-built batch scheduler like Unicorn to do more optimized and job selection or packing on the nodes to get the most out of utilization, to use something like Apache Airflow to essentially act as a job execution or processing gateway, right? And then the other part would be able to use something like Argo workflows to be able to drive these Spark executions. So, and then on the data lake side, there will be clean integrations on the output side to S3. And then you can essentially classify through something like AWS Glue while doing quick queries from Athena. The use cases there would be reporting and advanced analytics and ad hoc querying. Okay. So this is just one example of what we see in terms of data processing on EKS, and then another element, another workload that we see pretty often on EKS is machine learning. So what does Kubernetes for machine learning traditionally look like? So in this case, what I have is a representation of a desired state where data scientist or machine learning specialist is trying to train on 2 GPUs and using a host model of 10 CPUs. Using EKS as an orchestrator, we can then place these, and actually what we're seeing even here, the ability to use core binding, right? The ability to run on very specific GPU and compute instances. So this kind of speaks to some of the benefits of running Kubernetes for machine learning. Simplified AI training and inference deployments, better utilization of CPU and GPU resources, and then automatic scaling of heterogeneous GPUs and multi-GPU nodes. So this can be pretty powerful when combining Kubernetes and machine learning. And then here again, just a quick representation of that workflow. And in this case, taking even a deeper look into what that sample training job would look like, and when submitted to something like Keras for as a processing framework or a deep learning framework. So yeah, this is a quick example of that workflow. So what's one of the challenges here in terms of running this workflow? Well, this is not really friendly to use for data scientists, right? While a Kubernetes practitioner, this job manifest seems relatively standard. It's asking a lot to essentially ask your data scientist to be able to pick up a new language and being able to submit in this way when their normal experience really is happening through Jupyter notebooks, right? So one of the jobs and one of the challenges of platform teams is to be able to extract some of the complications, and really some of the Kubernetes specific language away to allow their customers to do their jobs better and without taking on a lot of this overhead. Another couple of challenges would be no ML experimentation or workflow management. Also, no ML specific features such as hyperparameter tuning, distributed training, model hosting, right? So it's relatively simplified in terms of the things you're able to do. So how do we get beyond this? How do we improve this experience? Well, one of the ways is Kubeflow on AWS, right? So Kubeflow is within the CNCF or the upstream community. It's a machine learning toolkit for Kubernetes. So within here, you're able to run notebooks. You're able to monitor and run pipeline executions, as well as do things like hyperparameter tuning and all within getting a deep introspective, a deep visualization into what's actually happening within your ML pipeline, both in the training side and the inference side. All right, and I should also state here that we also offer within this dynamic, and actually I'll show it in from this level, which is actually Kubeflow on EKS representation. Within kind of the image creation process, you can create your own container image, complete with different frameworks like TensorFlow, PyTorch, MXNet, or you can make use of some of the optimized like deep learning containers that we offer that are already optimized to run on EKS. That's one of the benefits of really running Kubeflow on AWS, is to be able to just take advantage of those images that are already available. And then also to be able to store the output of your training jobs to different data stores like EFS or FSX, depending on your performance or scalability needs, right? So, and then again, to be able to monitor both the pod and then the job executions within something like Amazon Managed Prometheus. So a lot of really good options for you to integrate with some offered managed service implementations to be able to run more cleanly these jobs at scale. Now, next, let's talk a little bit about some of the customers that have accelerated their data journey on AWS. And this is us really kind of focusing on some of the business outcomes. Here you'll see a number of different organizations that have saved, in the case of FINRA, managing 150 petabytes of data, for instance, at $5 per terabyte of data scanned. Or looking at Pinterest, for instance, reduced operational cost of 30% while freeing software engineers of work, really, that's not related to their IP. And there's a number of different examples here. We're going to talk through a couple of them in a moment, but yeah, we'll just talking about the ability to use a number of these managed service offerings together with EKS. That is it creates a very strong value proposition to users of AWS. Right. So just talking through a couple of these use cases, one would be Rivian. Right. So this one is talking about the challenge to the battery data science team at Rivian and how they used tools like or services like EMR on EKS to scale their analytics capabilities. Now, this was in combination with things like EKS for Fargate, MSK, which is managed streaming Kafka. For flexibility and development speed, right? The ability to use managed solutions with the popular open source frameworks for their maximum capability, right? Another use case that I have is with Babylon Health, using machine learning and EKS to bring accessible and affordable health to the hands of everyone of every person on Earth, right? That's the mission. So. Right. So this is an example of how they used EKS and EC2 Spot, which we've talked a little bit in terms of the ability to use them as flexible compute options, even within services like Spark. Well, they did so to scale to 300 plus applications and deploying in a highly decoupled manner, right? So utilizing great performance and high availability across the globe and reducing their average time to change from 4 weeks to a matter of hours. Okay. So, and the last example I have here, and this is again another machine learning example, would be from iRobot, right? And this was within their need to create a flexible machine learning platform that can run scalably across on-prem and AWS cloud. So they actually used Kubeflow on AWS, Kubeflow on Amazon EKS as a scalable platform integrated with a lot of those services that we've been talking about to drive their email experimentation, and also to leverage some of the AWS GPU compute options, right? So where do you go from here? So I've mentioned a number of offerings that we have available within our data on EKS repo, but for customers and that need more, well, we have a number of different ways that you can and AWS can work together to accelerate your journey, really in a number of different dimensions, be it analytics, AI, ML, real-time streaming, distributed databases. So really within this modern data platform motion, there's a lot of different areas that we can help. One is through migration assistance, what we call MAP, right, where we'll provide different funding alternatives and funding assistance to make it easier to move. And then others would be able to. We're aligned with a number of different partners, folks like Starburst, DataTracks, to do a number of implementations. It could be Trino, it could be Cassandra, it could be Spark. So we do have a list of partners available to help, depending on what the domain technology is, or even in the implementation of a data strategy. Your data strategy could be data mesh strategy, for instance. And then data labs, and this is something that I'll mention in a minute, but this is and actually maybe I'll move on to it now. Just wanted to quickly mention ProServe, right? We have the ability to offer different ProServe resources to help hands on keyboard, with some of these build outs. And then also immersion days. These would be offered by AWS SAs that are solutions architects that are trained in these workloads and have really seen them and work with customers at scale to deliver them. So going back to data labs, so this is actually the use case or the reasons why folks would use data lab in this context is it's a joint engineering engagement between your team and AWS experts that accelerates your use case. When is it available, or when should you use it? Well, it's when you have a clearly stated business use case, and then the solutions themselves focus on things like databases, analytics, ML, also different things like serverless and container modernization motion. So it's really it's a really strong complement for folks that are looking to run data workloads on EKS. And then the outcomes of those would be the ability to accelerate your cloud projects in days, not months. These typically, so using a lot of the IAC and the accelerators that we offer within the data on EKS repo, we've certainly been able to cut down the time to implementation, at least on a lot of the operational components or infrastructure components, to smaller windows. This is actually this itself offers a strong enablement vector to cut down that time as well. And this one in cooperation and hands-on in the development of a full end-to-end use case, right? So, and at the end, it's also complementary, right? This is an unpaid engagement. So they offer two types. One would be a build lab with both the architecture and prototype. And the thought here being that this is for the kind of the creation and re-architecture of existing re-architecture, or the creation of improvement of existing architecture. Also, the ability to build a prototype with AWS's learnings and guidance. So it's typically a 3 to 6 week engagement. And then also a couple of preparation calls. So again, it's 2 to 5 days in terms of total consecutive days. But what you get out of it is a working prototype with a solidified design, something that's really meant to scale to production post lab. And the other part of that would be if you just need architecture support, recommendations, and so on. You're not quite ready to build yet. The ability to do a design lab, right? So this is again a couple prep calls and shorter full number of days in terms of total time commitment, but out of that, you'll get a post-lab report with architecture design and recommendations. So this is something you can use to enable your future build. So with that said, I just wanted to thank everyone for attending and pulling this session. Again, my name is Brian Hammonds. This is my contact information below. And with that, I'll open it up for question and for Q&A.